Thanks everyone for coming. This is my name is Faisal Dada. I'm from Xilinx, and here on the stage with me we have Mr. Zhaijin Gao from China Mobile Corporation, and we're going to be talking about network slicing and slice packet networking for 5G services. So without further ado, let's quickly go through what we're going to be talking about. We're quickly going to do some introductions, which I just did, and then I'll talk about why we need network slicing for the 5G network, and then we're going to dwell into how the operator's view of 5G network slicing looks like. Is it hard network slicing? Is it soft network slicing? And some data from China Mobile on what they are planning on network slicing. So if you look at 5G applications that we have to look at, there are many different diverse applications for 5G, and we have applications from user equipment, that is handsets that we use. We have automated driving, self-driving cars. We have smart cities, smart homes. We also have a lot of IoT, as well as telemedicine that's going to come into play. If you look at all of these applications, key element to these applications is some elements require different facets from a network. If you look at user devices, they require a lot of bandwidth. If you look at self-driving and automated cars, we require a network that is very sensitive to latency, which is extremely reliable. If you look at smart homes, there's security elements to it and there's density elements to it, because we'll have lots of devices that are connected to the network. If you look at telemedicine, on the other hand, it's extremely reliable. It has to be extremely secure because the data is very, very confidential on those networks. As we continue, we look at smart cities, density, security, latency, all of those things come into play. So as we look at 5G, what does 5G bring to the network? We talked about all those applications, but there's another application in 5G which is called enhanced mobile broadband. That means access to a lot of wide variety of people, wide variety of devices at very, very high data rates. If you look at what EMBB does to the network, the demands for bandwidth on that network are extremely significant. So what does 5G mean? 5G means we need bandwidth, we need latency, very low latency, we need highly reliable networks, and they're very, very competing elements on a network that are demanded as a service from the network. So let's look at the vision of 5G, right? If we look at the vision of 5G as IMT from IMT 2020, we look at we need 3x higher spectral efficiency, and we can try to envision what it does to the network. So we need more spectral efficiency. We need more connection density. At some point, you're going to say there's going to be trade-offs in the network, but we want 10x more user experience throughput. That means the user has to be connected and has lower latency, more connectivity to the user. Well, we need 100x traffic capacity. At some point, we'll need 100x network inefficiency. If you look at all these parameters, we're asking more and more and more from our network. There's nothing that's been given up on the network. As it is, networks are very highly loaded, and we're asking for significant more impact from the network. So there is something that 5G gives up, and there's something that we need 10x less of. But that 10x less of is latency, which is actually a significantly larger problem as well. So we need more capacity, we need reliability, and we need it at lower latency. It's a very, very difficult process to solve. So how do you solve for this process, right? So the demands on the network, when we look at what's being asked from a network point of view, we need higher capacity, but we need it to be extremely reliable. We need lower latency, but we need it to be extremely secure. Typically, security and latency don't go hand in hand. Reliability and capacity don't go hand in hand. Lower power and complexity and flexibility don't go hand in hand. We believe that those are orthogonal demands on a network. And ultimately what happens is the network, a single network, will not be able to provide everything. It just does not scale. It just doesn't work that way. So we need a methodology that allows the requirements on the network for a service and application to be matched together. And that is what network slicing comes into play, right? And we're defining that from our perspective as something that allows matching of the network's characteristics to the needs of the application and the service. Just quickly looking at what network slicing means, you can see a very simple facet here. We have different services that need to go to different types of users. So on our left-hand side, you have banks and governments, which might be enterprises. You have cars. You have industrial IoT. You have a significant amount of smart city applications. You have user devices, which are handheld sets. And of course, every one of us now watches Netflix at home, so we want to have capacity to be able to view video, high capacity video at home as well. So we have everything that is connected to the network. And then we have different kind of services that are driving these networks, right? You have the internet that is up here in the center, but you have mobile edge compute that might be connecting your CU or central units down to your user elements or your handsets. You might have automated driving that might be talking back to their headquarters to define updates, information related to that automated driving. You might have secure services that are coming from government that are being downloaded, or enterprises that are being downloaded directly and delivered to you on your handset, right? If a kid is born, maybe you can apply for their birth certificate or handset. That needs to be an extremely secure connection. All of these services now need to go through the same network pipe. We need to look at it as a single channel that exists, but within that channel we have different parameters and different services, different needs that need to be delivered through that single channel. And that's where enhanced mobile broadband comes into play, IoT comes into play. That's where things like fixed access, that might be delivery of internet to your home, comes into play. Secure government, ultra reliable, low latency connections come into play. So ultimately, network slicing will allow us to match those services to the different kind of users. So what we've done is we've asked CMCC to join us here. Mr. Gao has been really generous to donate his time and come here and talk to all of us. We asked them some really important questions. Does network slicing here that we talked about, does that align to a network point of view? Is that what the network requires? Is that something that CMCC needs in their networks? And what kind of services do they envision in a network? So I laid some out. That's what we hear. That's many people talk about it. But is that something that CMCC really sees, or is that just hype? We need to be able to understand that, and that's some of the questions that Mr. Gao will be answering. What is it that network slicing will envision, and what kind of services will that enable in the network? Will they be giving them more revenue to be able to deploy this new network? Because if it's a large build, that build implies that there is going to be a significant amount of capex that happens. What are the services that are there that are going to pay for that capex build? And then ultimately, how do they envision these slices to be implemented, right? Are they soft QoS in a packet? Are they TDM slices, very, very hard and rigid, or are they a mix of both of those? So without spending much time and not adding any value to this conversation, I'll hand off to Mr. Gao, and he'll be discussing the view from CMCC.
Okay, thank you, Faisal. Hello, everyone. Thanks for Xilinx invitation. And here I will share some information about the slicing packet network and also some considerations on 5G network from China Mobile's perspective. Okay. Okay, for the requirements and the challenges from the 5G transport network, we can see that the usage scenarios is somewhat different from the 5G network. That gives some new requirements to our transport network. And from the architecture, from the bandwidth, latency, and other issues. First, I will give some architecture considerations for our 5G RAN. China Mobile just, I think, announced the Open RAN project in this year's Mobile World Congress. And we can see that from the architecture, the function split of the 5G RAN defines the centralized unit and the distribution unit. We can use in two modes. One is integrated, and there is a new radio base station, and another scenario is CU and DU, the separate usage. And from the CU and DU, you can see that middle haul and the backhaul were overlapped and has a unified transport technology. So the middle haul and the backhaul, from China Mobile's perspective, we have the same requirements. And under this scenario, the slicing and the layer 3 function are needed. And the front haul, we can use the fiber connection or use a channelized network solution with DWDM. And for the bandwidth estimation, China Mobile estimates the bandwidth according to the standard from the ITU-T and 3GPP. And we have considering under two scenarios. One is a lower frequency solution, and one is a hybrid low frequency and high frequency station solution. You can see that for the bandwidth, the low frequency station solution is around 3 gig, and for the hybrid, we can see that the access layer, we need about 140 gig bandwidth. So for the backhaul, you can see that the core layer and the aggregation layer, the estimation bandwidth is about 100 gig to 600 gig. And the access layer, the client side, we can see that the network interface bandwidth is more than 25 gig. And for the middle haul, the bandwidth is around the same as the backhaul. And for the front haul, we can see that for the single RRU is on 25 gig. So the front haul has different requirements from the backhaul and the middle haul, and should be based on the optical technology. So for the traffic model, we can see that the traffic flow between the crowded MEC is increasing dramatically. And there are several scenarios from our network architecture. So the local mesh network may be applied to aggregation, even access a layer of the 5G transport network. And the layer 3, the function, should move to aggregation, even access layer. So for the latency analysis, we can see that the requirements range from 1 microsecond to 10 microsecond, according to the different architecture, the pizza box of the chassis box. And we also do some lab test for our tri network in the lab. And our partners is Huawei, ZTE, and Fab Home. And we can see that the lab test results is just same around the requirements. So for the time synchronization requirements, we can see that for the 4G, the total end-to-end budget is around 1.5 microsecond, and for the 5G, according to the estimation, should be around 200 nanosecond. So the multi-layer interface need to be supported, and the B should be used in the front haul and the access layer of the backhaul. And compared with 4G, the time source and time transmission technologies are required to improve time synchronization program. So all these requirements concluded, we can see that there is requirements for the slicing, the network slicing of our transport network. So the network slicing as a service is very important to our next generation 5G transport network. And the slice based on TDM and the slice based on packet should be supported. And the VPN and the HQS cannot meet the both requirements of for the hard and soft isolation. So there's some consideration for our network, the planning. According to the evaluation, for China Mobile, the 5G has many new requirements on the transport network. So the 5G transport needs revolution, new technology, new chips, and new boxes. I gave some details of the requirements from the packet layer, link layer, and the time synchronization and the control management. You can see that there's some details requirements for different layer. So next, we consider the solution. So during the Mobile World Congress this year, China Mobile, working with our partners, we have announced the slicing packet network solution for the 5G transport network. This solution just merge the TDM and the packet technology. So you can see that we can use one sentence for this solution is segment routing transport profile over slicing Ethernet and over DWDM. And also comply with our next generation network, the control panel we were using the SDN controller. So the slice gave the migration from the 4G to 5G, and you can see that for the slicing packet network, the requirements in different according to different the technology issues. So next I will give some architecture introduction of our slicing packet network. For our slicing packet network is based on slicing Ethernet and the segment routing transport, and combined with the DWDM and random. But for the China Mobile, we use the DWDM in our current network. And so random just the option consideration for our next generation transport network according to different scenarios, especially in the large cities. For example, the Beijing, Shanghai, and Guangzhou. There are some requirements, maybe some requirements from the random. So from the 3 layers of the slicing packet network, you can see the key technology we will use. And for the slicing packet layer, the most important is the segment routing. And for the slicing channel layer, we will use the slicing Ethernet. And for the transport layer, we will over DWDM. So for the details of slicing packet layer, we can see that the segment routing and also the SDN-based layer 3 VPN. That's 2 most important issues we are considering. And for the slicing channel layer, there is a SPN channel and also the Ethernet cross connection and also the SPN channel overhead. These 2 key facts we are considering. And for the slicing transport layer, we can see that different requirements for the part of our transport network. For aggregation and core network, there should be the color light to support DWDM. And there are 2 possible solutions. One is the direct detection modules, and one is the coherent detection modules. And according to the information from our vendors and partners, it seems that 100 gig and 200 gig coherent the modules is module, but still high cost. So I think for the carrier, the cost is always the issue, the important issue of our network. So for the access layer, you can see that we need the green light to support 5G and 100 gig. So there are 2 possible solutions, the 5GE PM4 and the 100GE. And for the front haul network, the solution mainly use the fiber direct connection, the passive WDM at 4G. And for 5G, the multiple fiber can be used. And also the SPN, the light, the device can be used for multi-service, multi-interface convergence. And we need to fulfill the unified management of our front haul, middle haul, and backhaul. So you can see that from the slides, our target is one network to meet all mobile, residential, and enterprise service. Next, I will give some considerations of SPN equipment. We have already finished the lab test with our partners, Xilinx, the Huawei ZTE Fab Home, and also there is a booth, there is a demo in OIF, the booth, yeah. So for the considerations for the equipment, there are three important issues. One is packet switching and the slicing Ethernet cross-connect is required and should be supported and multi-integrated. And the ROADM, I just mentioned, the ROADM is optional. For our current network, we directly use OTN in our current network. And according to the requirements for the next generation transport network, maybe ROADM will be introduced in some scenarios. I just mentioned that, for example, in our large city, the network, Beijing, Shanghai, and Guangzhou, maybe we'll introduce the ROADM according to the requirements from the service. And another important issue is slicing packet network. We want the block design. That means the electric layer and the optical layer of the equipment can be a flexible combination according to different application scenarios. So you can see that from the slide, the total design is a building block design. So I just mentioned that we have finished the lab test of slicing packet network in our lab, and also China Mobile gave the demo and the POC for the whole the technology, and working with our partners, and we will have the single vendor scenario and also the multi-vendor interoperation scenario. And according to the lab test, the results meet our expectation. So that's why we announced the slicing packet network solution during the Mobile World Congress this year. So these slides give some introduction of the slicing packet network industry, the community. And we can see that the project just initiated from the 2016, just at the end of the 2016. And now we have issued the white paper during the Mobile World Congress this year. And right now, we are just carrying the field test around with our 5G wireless child network. So I give some conclusion about the slicing packet network. The first is the 5G transport network is facing requirements on re-architecture. So that I think that that's the same as core network. For China Mobile, we have already announced our next generation network architecture. That's called NovNet. And we will introduce the SPN NFV technology to our core network. And now, for the transport network, according to the 5G, the service requirements, we also need to re-architecture. So the unified transport solution for front haul, middle haul, and backhaul should make the network more efficient and more easy to maintain. So that's the target for China Mobile. And according to the 5G transport network, China Mobile think that there are some key technologies. One is new architecture. According to our slicing packet network, we use segment routing, transport profile, over slicing packet, over DWDM. And for the link layer, we need the end-to-end slicing, the link aggregation, and the channelization. And for the packet layer, we need the segment routing and the carrier grid layer 3 VPN. And also, we will use SDN control in the control layer. So according to our lab test and field trial, we think that the slicing packet network solution can meet China Mobile's 5G requirements. And China Mobile now is doing the field trial, and we will be the results, I think, will be get in the Q2 this year. Thank you everyone.